In our last science of candy making video, we tried to make fudge. I was hoping to show how cooling time would affect the crystal size and the graininess of the fudge. It didn't really go as planned, so in this video we're going to talk a bit about the scientific method and some of the things that might have happened. Much of the science of candy making has to do with controlling the sugar crystal growth rates and size. There are several factors that can affect this, including temperature, rate of cooling, humidity, and ingredients. I wanted to demonstrate how rate of cooling can affect crystal size. So what did I already know about demos such as this? In the past, I had seen a demo in a kid's science book using fudge to show the relationship between crystal size and cooling time in igneous rocks. I even used this demo once in the class I taught. But the problem was I couldn't remember where I had seen this demo mentioned previously and couldn't track it down to check the procedure that was used. So I relied on my memory instead. I may have forgotten parts of the procedure or important information about the conditions needed to make my demo work as expected. A hypothesis is an idea of how you think things might work based on knowledge you have and the observations you've already made. My hypothesis was that if I adjusted the cooling rates of my batches of fudge by leaving some at room temperature, some in the refrigerator, and some in the freezer, I could demonstrate different sized crystals forming, and that would affect the texture and graininess of the fudge. The next step is to test our hypothesis with an experiment. So I found a fudge recipe to make. But as I read through the fudge recipe, I realized you were supposed to cool the heated fudge before beating it. So I added another aspect to my experiment. Cooling rates of unbeaten fudge versus cooling rates of beaten fudge. So this was my second mistake, because a well-designed experiment will only test one variable at a time. So what is a variable? A variable is a change between the two conditions you are comparing. The control is the version where you know what will happen. The other version should change the condition you want to test in your experiment. In good science experiments, you only adjust and compare one variable or change in the conditions at once. This way you can know if the variable you changed is actually what might have had an effect. If you have too many variables changed, it is hard to know and gather evidence for which one caused the change. Was it cooling rate? The humidity? When you chose to stir it? After you run your experiment, you need to collect data about what happened and figure out if it supported or refuted your hypothesis. There were a few problems with our data collection, including testing sample size, confirmation bias, and limits of our testing equipment. But what do we mean by these things? To collect statistically significant data, you need a large enough sample size of testers, and I only had 3 taste testers. Also, my taste testers were not a randomly selected sample. We were all in the same family, meaning we might share some of the same biases in our interpretation. Another issue was our taste test was not a double-blind study. A double-blind study means that neither the person giving the samples or the taste testers know which samples are which. All of our taste testers knew which sample was which one, leaving our results open to confirmation bias. Confirmation bias means our expectations of what we thought the results should be can influence our interpretation of our experience in the results. There are 2 types of evidence we can use: quantifiable and qualitative. Quantifiable is something we can measure in a specific way with equipment. As an example, in this case, it would be if I had used my microscope to be able to get exact measurements of the crystal sizes. I lack the way to make these measurements with the microscope I have. Qualitative evidence is more subjective. It is based on people's interpretation of what they see and sense. So our taste test would be qualitative, since the data collected was dependent on the person's ability to taste and feel the graininess of the fudge. We could detect very little difference in our taste test. This could mean either there was no difference, or that the difference was too small for us to be able to detect by taste. So our experiment didn't work as planned. Anything from working with too many variables, to our informal qualitative testing of results, to not remembering the procedure, to not enough difference in the cooling rate could have been a factor. But also, after doing a bunch more research into fudge making, it maybe was the experiment just would not have worked that way anyways. When we make fudge, we are making a supersaturated solution of sugar. Sugar crystals falling out of solution too early can provide seed crystals in time for larger crystals to form. This can happen with sugar crystals that are undissolved early in the process, such as sugar stuck to the side of the pan. This can also happen if the fudge is agitated before it has a chance to cool to the beating temperature. When we beat the fudge after the cooling time, we form many seed crystals, none of which get too big before the cooling is complete, instead of having seed crystals that have a long time to keep growing. But what about the fact I had done this demo before and had it go the way I expected? One of the really important factors in the scientific method is repeatability. Can other people follow your procedure and conditions to get the same result? If not, there are some other variables in effect, and the hypothesis you are trying to back up with the experiment is not supported. While I had gotten the expected results once before, I don't have a history of repeating the experiment. It is possible that my first successful attempt was somehow flawed or had different factors in play. In order to figure out which demo was more correct, I would need to do the experiment more times to see what results I most consistently got. And then other people would need to be able to replicate those results when they did the experiment. In our next video on the science of candy making, we'll explore making caramels. I'd like to thank everyone for watching, and if you enjoyed this video, hit like and subscribe, and I'll see you next time.